Okay, so we're going to continue on with our inheritance discussion and go over again the concept of overriding a method. So we say a child class can override the definition of an inherited method in favor of its own. So what method did we override in our child class yesterday? Two string. And then we made reference to the parent two string and then added something more. When we do override, the new method must have the same method signature as the parent's method, but it can have a different body. The third bullet point is the key. The type of the object executing the method determines which version of the method is invoked. So let's jump out and take a look at these three files. So we're going to start with the child class, thought. In thought, we have a method called message. That's it. I'm not a big fan of this class because it doesn't even have a constructor. It just uses a default constructor. So it has some message about being diagonally parked in a parallel universe. Now let's go to the parent class. Advice. We have a we're overriding message, and in this class we print warning, dates and calendar are closer than they appear. We ask for a new line, and then we refer to the parent's message. Now this is different than a constructor. In a constructor for a child, if we want to use the parent constructor, we have to say super first. But that's not the case if we're referring to any other method that is not a constructor in your child class. So what we should expect to happen if we call an advice object, if an advice object calls message, we would expect it to print the warning statement and then jump back and go to the parent class and print this message. So if we go to the driver program, you can see that we've created two objects, a thought object and advice object. For the thought object, we call message, and for the dates object, I'm sorry, the advice object, we call message again. And the overridden, this implies that it is the child class. Okay, so if you haven't run it, go ahead and run it so you can see the difference between printing the parent and the child. So there's two words in Java that sound very similar: overloading and overriding. So you got to keep those two concepts clear in your brain. Overloading deals with multiple methods with the same name in the same class, but they have different method signatures. Whereas overriding deals with two methods, one in a parent class, one in a child class, but they have the same exact method signature. And that's the only way overriding will work. Overloading lets you define a similar operation in different ways for different data, but overriding lets you define a similar operation in different ways for different object types, and those object types will be in a class hierarchy, like we saw with toString. So this is not the best diagram ever in the history of all diagrams. I'm going to see if I can fix this a little bit. Whole thing needs to move. Oh wait, that's just making it worse. Aha, there we go. Okay. So we have parent, child level, grandchild level. A child class of one parent can be the parent of another child, forming a class a hierarchy. So we have parent child relationship going from this level to this level, but we also have a parent child relationship going from the middle level to the bottom level. Notice again when we draw our class hierarchies, the way the arrows point, they point back towards the parent. Two children of the same parent are called siblings, just like you are in your own real life. Common features should be put as high in the hierarchy as is reasonable. So that means when we're looking at a class hierarchy, as many of the pieces of instance data and as many of the methods all the members of our hierarchy are going to need should be in the parent class encoded there. That way we don't have to code as much, and we only have to code, override, and create instance data and methods that for the child and the grandchildren, we only have to do things that make them different from the parent. An inherited member is passed continually down the line. So that means if something is public in the parent, it is available down at the grandchild level. And then if we created great great grandchildren and so on, everything the parent does that's public would still be available at those lower levels. A child class inherits from all of its ancestor classes, and there is no single class hierarchy that is appropriate for all situations. So what they're trying to say is you basically have maximum flexibility in how you want to lay out your hierarchy. The only real criteria is that you can only have one parent. At least in Java, you can only have one parent. Any questions? All right. So now, I have been saying for a while that the object class is at the top of the hierarchy. It is the parent of all classes. And that at that point in time, you might not have really understood what I was talking about. But it truly is. Every class that you create is actually a child of the object class automatically by default in Java. We never say extends object when we make a class. It's kind of done in secret, invisibly. Kind of like the same way when we print the reference to an object, it looks for a toString method. So we say a class called object is defined in java.lang package of the Java class library. All classes are derived from the object class. It is the parent of all classes. If a class is not explicitly defined to be the child of an existing class, it is assumed to be the child of the object class. Therefore, the object class is the ultimate root of all class hierarchies. Let's take a minute to go to the API. So I'm going to go Java API. We've been here before. Let's look for the java.lang package. And then I'm going to scroll down to the object class. So every object gets a default constructor. And then here are all the methods that every object gets. Some of them are familiar to us, like the equals method and the toString. Returns a string representation of the object. By default, if you don't code a toString, what you get is something called the hash code for the object, which I just call Java garbage because it's pretty meaningless to us at the end of the day. So there's your constructor detail for an object. And then if you go back to the top somewhere, oh, I guess not. Okay. Any questions about that so far? So the object class contains a few useful methods inherited by all classes. For example, the toString, which we've been using. Every time we have defined toString, we have actually been overriding an existing definition. So by default, toString in the object class will return a string, and like I said, that happens to be the object's hash code, which you'll learn about in a second version of or the next computer science class.